I was recently flabbergasted when I discovered how the Bureau of the Census calculates the center of population of the United States following each decennial census. Frankie Barmore, 1991. Now, for those unfamiliar, the U.S. Census attempts to count every resident of the United States. It was established all the way back in 1790 and is conducted every 10 years. Since 1870, the Census Bureau has also published the coordinates of a point marking the center of population of the United States. This point, the mean center of population, essentially represents the average location of everyone in the United States. This is also known as a balance point, which would be the point at which a flat map of the United States would balance if every person in the country were to stand on it at their location. There is also a median center of population, but we're not going to touch that, as the Census Bureau applies the term center of population to the mean center of population, not the median. In 2020, the mean center of population of the United States was here, 14.6 miles northeast of Hartville, Missouri. That's nice. Hartville, heart of America, cool. It's a shame it's wrong. So why is this point wrong? Is the data wrong? No. Well, people are born and die every day, so it can't be perfect, but it's as good as we're going to get. It's actually the method the Census Bureau uses to calculate the center that is wrong. We're going to use the Census Bureau's own data from 2020 and get a result that is much more accurate than they did. So let's talk about that data. As I'm sure you know, the US is broken up into 50 states as well as a handful of territories. For this calculation, we're only using the 50 states and the District of Columbia because that's what the Census Bureau did. For census purposes, each state is broken up into a number of census tracts. These tracts are then broken up into census blocks. Each census block lists the population living within its boundaries, as well as the block's longitude and latitude. Using this information, we can multiply the population of each block by its longitude, sum them up, then divide by the total population of the US, giving us the average longitude value for the country's population. Then we can do the same with latitude, giving us the coordinates of a point that has the average longitude and the average latitude of the whole US population. Right here. 3.5 miles from the Census Bureau's point. These points are close because the Census Bureau is essentially doing the same process that we just did. The latitude calculation is exactly the same, but they add a small factor to the longitude calculation to recognize the convergence of meridians towards the poles. So why are both of these points wrong? Well, it's because the Earth isn't flat. Let's learn a little about map projections. A projection is a representation of the Earth's 3D surface onto a 2D plane, a map. Tragically, it is impossible to do this perfectly. In order to flatten the globe, you need to bend and stretch the surface. There's a bunch of different ways this can be done, but there's always going to be some sort of distortion. This is the Mercator projection. If you've ever looked at a map and wondered why Greenland is the size of Africa, this is probably what you were looking at. The Mercator projection is likely the most viewed projection because it's what most web maps use, including Google Maps. This projection drastically inflates the size of the areas closer to the poles. However, it's actually quite good for marine navigation because a straight line on this map is a constant direction in the real world. If you're in the market for a projection that doesn't distort areas, look no further than the Lambert Cylindrical Equal Area projection. All of the areas on the map are right, but the shapes are way off near the poles. Look at how squished Greenland is. Poor guy. Let's try something that's a little better near the poles. The Ellipsoidal Transverse Mercator projection, also known as the Gauss-Kruger. As you can see, it is quite good near the poles, but now South America is getting all distorted. Here's a fun one, the Dymaxion projection. It's got less distortion overall, but as a trade-off it's all chopped up. There are trade-offs for every projection, so to choose the correct one, you have to find one that fits your specific use case. The projection that we just used to calculate the average latitude and the average longitude is the equirectangular projection. Using this projection, longitude is just the x-coordinate and latitude is just the y-coordinate. Easy as pie. The factor I mentioned earlier that the Census Bureau uses to correct longitude means that they use this projection, a sinusoidal projection centered around the 92nd meridian west. However, the Census Bureau's definition of the mean center of population actually doesn't specify which projection to use, but this is the one they technically did use. You would think that they should specify one though. To this, our friend Frank E. Barmore from earlier said, Using the Bureau of the Census definition of the center of population, I believe that given sufficient time and mischievousness, one could choose projections of various orientations and center that would place the center of population at any place one wished. Go off, King. Like I said, there's trade-offs for every projection, but let's look at how this can manifest itself in the results of our calculations. Here's a population of 10 stars, and I want you to take a guess where the mean center of population is. There's 8 on the left near Canada and Alaska, and 2 on the right near Russia. Did you guess here? If so, you're right, using this projection. But the correct location using a globe is actually here. If we actually look at it on the globe, it's obvious. When we use the wrong projection, we get the wrong results. So, what is the right projection? It's a little complicated. This is the Azimuthal Equidistant projection. Specifically, it's centered around the North Pole. If this projection looks familiar, it's actually the one used for the United Nations logo. I just want to mention here that this is a precursor to the UN logo, and I think it's hilarious because they just rotated the projection a few degrees in a very transparent attempt to put the United States front and center. But I digress. The Azimuthal Equidistant projection can use any point as the center. Again, this is just the North Pole. Here's the South Pole. Here's Honolulu, Hawaii. Here's Buenos Aires, Argentina. Here's Ulaanbaatar, Mongolia. And here's Cairo, Egypt. What's special about the Azimuthal Equidistant projection is that measurements from the center point are accurate in both distance and direction. This isn't true from any other point on the map, just the center. This means that if the center point of the projection is the same as the calculated center of population using the projection, all of the distances and directions from the center of population are accurate, meaning it's the true center of population. If you're curious about what those stars from earlier look like on the correct projection, here it is. So, if the center we chose for the projection is the same as the calculated center of population using that projection, then it is the true center of population. But if they're different, our projection center is not the true center of population. If you've been keeping up, you might have noticed that this is completely circular. Not just the map, haha, but the idea that we need to know the center of population to choose the right projection to calculate the center of population. It kind of gets us stuck in an impossible loop. All we can do is guess and check. So let's guess. Let's try 0, 0. Is 0 degrees longitude and 0 degrees latitude the center of population of the United States? Here's our guess. In the Atlantic Ocean off the coast of Africa. Now, we're going to generate our projection using this guess as the center. Then we can calculate the center of population using this projection, and here are the coordinates. Are these the same point? Is the center of population of the United States off the coast of Africa? No, we can tell this intuitively, but here's the calculation to prove it. Our guess, the center of the projection, is over 6,000 miles away from the center of population that we calculated using this projection. So our guess was pretty bad. Let's make another guess. Let's make our second guess be the center of population that we just calculated using this projection. Alright, this wasn't right either. They're not the same. But at only 35 miles, it is way closer. Let's guess again using this new result. Under a mile. That's pretty good. But let's try again. So close. Maybe we can still get a little closer. the center of this projection the same as the center of population calculated using this projection? I'd say so. You can repeat this as many times as you want, getting closer and closer till it's nanometers away, but under a foot is close enough for me. So, this is it. The true center of population of the United States in 2020. Where are we? We are in Jefferson City, Missouri, the state capital. Apparently, one of the other name options that was considered for the city was Missouriopolis, which would have been sick, but whatever, missed opportunity. Regardless, are we done here? Not quite yet. I think that this method of successive approximation using the azimuthal equidistant projection is the best option, but there is one more worth mentioning. When our friend Frank said he was flabbergasted back in 1991, he proposed the method we just used and published it in a volume of the Wisconsin Geographer. In 2006, Edward Abuffadel and David Austin proposed a different method of calculating the center of population on a sphere. Their idea was, ignore the sphere. Up until now, we've been calculating distances along the surface of the Earth, but they proposed calculating the distances in a straight line from point to point through the surface of the Earth. The benefit of this method is that it's very simple to calculate. It can be done by converting latitude and longitude to x, y, and z coordinates and just finding the averages of each. Using this method on the 2020 census data, we get a result here, 7.5 miles away on the surface from the result of our azimuthal method. But it's not really here. Sure, it's at this latitude and longitude, but the actual 3D center is 115 miles below the surface of the Earth. You can pull it up to the top, but it's not really the 3D center anymore. It's a point 115 miles above the 3D center. I personally believe the azimuthal method is better than the 3D method because it uses the distances we actually use, those across the surface of the Earth. But you can make a case for the 3D method. So, the question you've been waiting for. How far away is the Census Bureau's center from the true center of population? Almost 80 miles. That's not like a rounding error or something, that's really far off. Here's the US state of Connecticut for reference. I mean, it's crazy. Now, I'm not the first person to recognize this discrepancy. We've already mentioned 2 papers discussing it. And a lot of work goes into publishing and publicizing the center of population, so I'm sure whoever is in charge of it at the Census Bureau is also already aware of the issue. And, as I mentioned earlier, the Census Bureau's calculation already includes a variable to recognize the convergence of meridians towards the poles, so they're aware of it at least in some capacity. So why on earth haven't they changed it? One reason is that it is easier to calculate it their way. In 1950, the Census Bureau's center of population was near Olney, Illinois. Commenting on the matter in an article in the St. Petersburg Times, census geographer Clarence Bachelet estimated it would take one person a whole year to calculate the center of population the way they were doing it, although the actual calculation was performed by a team. That is a huge amount of effort, and I respect them for putting it in so that we can have this cool stat. But it's not 1950 anymore. Computers are everywhere and have enough power to run this calculation or our successive approximation method in seconds. There is no computational reason for the Census Bureau to continue using their antiquated method. One other reason that may explain why the Census Bureau continues to calculate the center this way is simply that it's the way it's always been done. The center definition and method of calculation have been the same since the beginning. Inertia is real, and for a large change like this, I'm sure it would take some time. But again, it's been over 30 years since Frank Barmore's papers, so what's the wait? The real reason I believe it hasn't changed yet is that it's a part of history. As the center of population moves with each census, it highlights a new town, and that's an honor to the town's residents. Many of these towns have constructed markers or monuments to commemorate the arrival of the center of population. The center only began being published 80 years after the start of the census, so the first 80 years had to be computed retroactively. Any markers for those points were constructed long after the center had left their location. This plaque, commemorating the 1870 center, was created a century later in 1970. The plaque marking the center of population from the first census in Kent County, Maryland, was also installed much later, as were the markers for the centers in 1820, 1830, 1840, 1850, in 1880. The first permanent marker built contemporaneously with the presence of the center commemorated the 1890 center, which was found to be near Greensburg, Indiana, on the property of one Jacob Engel. And in 1891, a crowd of 5,000 strong gathered at a ceremony for its unveiling. This marker is still standing today, but in 1895, it was defaced. By this time, Jacob Engel had passed, and the property was now under the ownership of an individual named A.M. Armstrong. Armstrong himself defaced the monument by hiring a stonecutter to remove Jacob Engel's name from it. Reporting for the time offers no speculation at a motive, and I was unable to find any follow-up reporting on the case. Clearly, there is quite some history here, but it might be lost to the sands of time. And this wasn't even the worst time one of these monuments was damaged. In 1930, the center of population was found to be in Linton, Indiana, near a coal mine. In 1931, a monument to commemorate the center was built, fittingly, out of coal. But in 1937, it was taken apart and burned by a farmer to heat his home during a cold snap. A new monument was erected to replace it, but this one was built out of limestone in hopes that this new monument would stay put. These monuments or markers were usually erected by local governments to celebrate the honor of being the center. But in 1960, the town of Shattuck, Illinois did not get the memo. Apparently, they expected the Census Bureau would erect a monument at the center, which they obviously didn't. As a writer in the Youngstown Vindicator bemoaned in 1964, "The only guy on the ball so far has been an enterprising corn seed salesman who erected his own sign calling attention to the center." Now that's just good business. The thing about the center of population is that it's almost always just out on a farm somewhere. For example, in 1900, the center was located on a farm owned by one Henry Marr, who the Indianapolis Daily News declared was the nation's center man, which is just awesome. This point was technically closest to Wiggs, Indiana, which one writer in the New Richmond Record in 1901 declared would not be a good place for a dogfight, let alone the center of population of the United States. The writer declared that Columbus, Indiana, only 6 miles away in a thriving city, was entitled to claim the distinction of being located at the center of the United States. 6 miles southeast of Columbus was the descriptive definition used by the Census Bureau that year, who tends to use larger towns when describing the center's location. Sometimes these centers also kind of move. In 1910, the Census Bureau declared the center to be in Benton Township, Indiana, 6 miles west of Bloomington, Indiana. However, a multiplication error was found, and eventually corrected, landing the center right in the middle of Bloomington, on the lawn of the Shower Brothers factory. Shower Brothers saw a marketing opportunity, a celebration was held, and a marker built. This marker was eventually moved to a park in Bloomington after the factory closed down and the marker was in jeopardy of being destroyed. Sometimes the center moved because there were issues pinpointing it in the first place. Typically, after the public release of the coordinates, citizens would try to determine the center based on the Census Bureau's information, which wasn't easy before GPS was available. Their location wouldn't be verified until later by astronomical calculations. This happened in 1940 in Carlisle, Indiana, when the center was moved from one farm to another after the official results came in. Apparently, this change didn't matter a great deal to the residents, as long as the center was still in Carlisle. It also happened in 1920 when the center was in Spencer, Indiana. The marker was originally placed at the farm of Jimmy Herron, but was moved after Professor Coggeshall from Indiana University's astronomy department determined it was actually 2 miles away at the farm of Melvin Sims. This didn't seem to sour the citizens on the whole project, as in 1927, the citizens of Spencer decided to name their high school basketball team the Cops, an acronym for Center of Population. Unfortunately, Spencer is not the only town that built a monument commemorating the center of population in 1920. On June 26, 1925, the Daily Independent in Murfreesboro, Illinois reported that the citizens of Lawrence County are elated over the announcement that the center of population, as revealed by the last census, is a point near Ambraw River in Allison Township. It is proposed to erect a monument or marker to designate the exact spot. And they did. But this is not like the other markers we've seen. The inscription reads, Center of Native White Population. USA, Census 1920, erected by America's Boy Scouts. Now, publishing centers for different groups is a reasonable enough idea in theory, giving us a chance to see the movement of different subpopulations over time. They published centers of population for the urban and rural populations. However, they also did it for a couple of other groups, the black population, the foreign-born white population, and the native white population. Now, moving past the oxymoron of native white in this context, I think we all know exactly what they were doing here. The decision to split up the population specifically like this is just one in a long history of attempts to declare the US-born white population as the real Americans. Thankfully, the Census Bureau did not continue publishing the subpopulation centers like this, and to my knowledge, another marker like this was not erected again. With the exception of this one marker, I see the center of population as a monument to inclusion, where all Americans are counted the same, which sometimes feels rare. And as we've seen many times, the center is a point of pride for the towns it has passed through. In 2010, a resident of Plato, Missouri, the center at the time, is quoted as saying, "It is putting a spotlight on a corner of the world that doesn't get much attention." In 1970, when the center was in Muscoda, Illinois, a headline read, "Fame comes to Illinois town as U.S. center of population." In 1980, when the center was in DeSoto, Missouri, the governor declared June 5th of that year, "Show me the Center of Population Day." The celebration was held for the occasion, with the representative of the district, Bill Emerson, in attendance, among others. Interestingly enough, in 1990, when the center was in Steelville, Missouri, Emerson was in attendance again, representing the district, as he had switched districts from the 10th to the 8th, making him represent the center in consecutive censuses. That all brings us back to today, the 2020 U.S. Center of Population. Now, it's still wrong, and it was calculated the same way all the others were, making them all wrong too. And that's a shame. There's a lot of history and pride for the towns involved, and to change the calculation would be taking away the honor bestowed on the people of these towns. It's a cool thing to be able to say, "I'm the literal average American," and that your town in some way represents the entirety of the United States. There is something to be lost here, but the fact of the matter is that these calculations are done wrong, and in the age of technology in which we live, there is no good excuse not to change it. In fact, the Census Bureau's own mission is to serve as the nation's leading provider of quality data about its people and economy. I would not consider 80 miles off as quality data. So, it needs to be changed. And besides, what's the alternative? Continue to be wrong forever? If you couldn't tell, I love the Center of Population. I think it's an amazing way to commemorate the people of this country at a point in time. There are many, many people that have been long gone and forgotten, except for the impact they made on the location of one of these points. Although I really hope the Census Bureau fixes their calculation, I hope more strongly that the Census Bureau continues to publish the Center of Population as long as the United States of America continues to exist. One of the coolest Center of Population projects I've come across was in the year 2000 when the NOAA, the National Oceanic and Atmospheric Administration, collaborated with the Census Bureau and the individual states to place markers for the centers of populations of all 50 states. Not all of them happened, for goodness sakes, Hawaii's Center of Population was in the ocean, but many of them did. So, I'm going to leave you with a montage of the markers of these state centers of population from the year 2000. Maybe, if you're close, go visit yours or something. Thank you for your time.